Okay, my friends, are you ready to finish this? It's actually very simple now, and I'm sure that you're confident that the solution I'm about to give you will be the same as your solution. Because indeed, now the only thing that we have to do is juggle with our different machine learning toolkits, including the data preprocessing toolkit and the classification toolkit, to complete this implementation. So let's do this, starting with splitting the dataset into the training set and the test set. Well, that's super easy. We're ready to do this in only one copy-paste because we have indeed the matrix of features X and the dependent variable vector Y. Therefore, the only thing that we have to do here is just to go to our data preprocessing template and then take exactly these two lines of code to indeed split our data set composed of the matrix of features X and the dependent variable vector Y into, well, a new training set and test set. And that's our first copy paste. And of course here we have nothing to change. Now, next step, training the naive Bayes model on the training set. So here we'll have to juggle with another of our machine learning toolkit, which is of course the classification toolkit. So we're gonna go back into our whole machine learning A to Z folder. Then we're gonna use this little shortcut here to go back to the base of the folder, which is this one, machine learning A to Z, codes and dataset. Then we're gonna go into part 3, classification, and then we will see all our different models, including the naive Bayes. But I would just like to remind that, the choice of naive Bayes was just based on my experience. I observed that the naive Bayes does very well with natural language processing problems, but I'll give you another exercise at the end of this tutorial, which will be to beat me, or to beat the score that we're gonna get at the end of this implementation. And so your goal will be to get an even better accuracy. And if you get it, you'll post it in the comments, or you can send me a private message to say that indeed you managed to beat the accuracy score that we're about to get together and that you probably got by yourself when doing this exercise. Alright, so there we go. Let's just choose for now the naive Bayes model. So we're going to go into the section 18 naive Bayes. Then we're going to go into Python. And then we're going to open this naive Bayes implementation. Open with Google Collaboratory. And, I can just put it here. It is now opening, loading it, laying out the notebook. And there we go. And now you have everything. You can just find the cell that, trains the naive Bayes model on the training set, which is right here. By the way, you could also take, your model selection folder containing all the classification models as you want. But there we go. What we need right now is this cell and nothing else. And we actually don't have anything to change inside. So that's all good. Now let's go back to our copy of our natural language processing implementation. Let's create a new code cell here. And let's just paste that cell to train, well, the Gaussian naive Bayes model on the training set composed of X-train and Y-train that was just created just before. All right, good. Now, next step, predicting the test set results. Well, once again, here we won't have anything to do except a simple copy-paste still from our naive Bayes implementation, because, what we just want to do here is display next to each other the vector of predictions and the vector of real results containing the real reviews, the real outcomes of the reviews, whether they're positive, which gives a 1, or negative, which gives a 0. So here I just copied and I'm about to paste that here in a new code cell. All right, and this will indeed print next to each other, first the vector of predictions, which we got here in this first line of code, and the vector of real results containing the real outcomes of the reviews. Perfect. And finally, making the confusion matrix. That's our last step here. And once again, we're going to go back to our toolkit, the classification toolkit for naive Bayes. We're going to scroll down a bit more and we're going to find indeed the confusion matrix, computing as well the accuracy score. The accuracy being simply the number of correct predictions divided by the total number of observations in the test set, of course. All right, so let's copy and paste that in this new code cell, and there you go, my friends. Now this implementation is over. We finished it in just a few seconds, or in a few minutes with the explanation, but there we go. That's what I mean by juggling with your different toolkits. You can be super efficient at implementing a classification or regression model by using your code templates. All right, now it's showtime. We will execute the cells that we haven't executed so far. So the last one we executed was this one. Basically everything that is related to the bag of words model. So now let's play the rest of the cells, starting this one, which will split the data set into the training set and test set. All good. Now that we have the training set, we're going to train the naive Bayes model on the training set, and all good again. And now we're going to predict the test set results by displaying next to each other the vector of predictions and the vector of real outcomes of the reviews. And well, wow, look at this. We don't start well because we start with 3 incorrect predictions, right? For the first review, which, be careful, is not wow, love this place, because these are the reviews of the test set, not the whole data set. So this is not the first review, wow, I love this place. This is just a random review taken from the original data set and put into the test set. But anyway, for this first review of the test set, our model predicted this review to be positive, whereas in reality it is negative. Same for the second review, predicted positive, but in reality negative. Same for the third review, predicted positive, but in reality negative. And then this is correct. That's a negative review, which was indeed predicted as negative. Same for this one, negative review predicted as negative. Here, another mistake. Negative review predicted as positive. Here, correct prediction. Positive review predicted as positive. Then incorrect prediction, negative review predicted as positive. Then an incorrect prediction again, negative review predicted as positive. Then correct, 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 incorrect. Anyway, so yeah, but by scrolling down, we can see, that we actually have many correct predictions. And anyway, we're going to check that right away with our confusion matrix below. So I'm actually going to scroll down from here. There we go. And perfect. So this is our last cell, which will display the confusion matrix and compute the accuracy score, which I will want you to beat right after this tutorial as a final exercise of NLP. And so let's play this cell to see what the confusion matrix looks like, and mostly to see the final accuracy, which is 73%. All right, so that's pretty good, but I'm sure we can do better. There are many ways to do better. And so I really look forward to seeing your results, after you experiment with more classification models, or even by doing a better cleaning of the text, the reviews. Maybe you can add some more exclusions in the list of stop words. We excluded not from the list of stop words, but maybe you can exclude as well isn't. I know that isn't is actually part of the stop words list. So, you can do some extra work in order to improve this, because I'm sure that we can get a better accuracy than 73%. But still, this is pretty good. Remember that we actually trained a machine to understand English. And a couple of years ago, maybe decades ago, this would definitely seem very challenging. But here we did it in just a few minutes. And so that's absolutely incredible. And the model predicts whether these English written reviews are positive or negative correctly 73% of the time. So that's really, really good. And that's the confusion matrix with 55 correct predictions of negative reviews, 91 correct predictions of positive reviews, 42 incorrect predictions of positive reviews, and 12 incorrect predictions of negative reviews. All right, so try to reduce these two numbers here and let me know, or let everybody know in the comments what you managed to get, which solution you managed to improve, and I look forward to seeing if you manage to, for example, go over 80%. That would be fantastic. You would definitely beat me by pretty far. All right, so now we're done with natural language processing. I hope you liked this introduction to sentiment analysis. If you liked NLP and if you want to, study more in depth this branch of machine learning, well, know that we have other courses about chatbots, about the BERT model, so I really recommend to check it out. But first, I recommend that you complete this journey of machine learning. And speaking of this, well, the next step of our journey here is to enter the fascinating world of deep learning, where we will, mimic the processes of the human brain to actually give for the first time to our AI an artificial brain, which will itself perform some predictions. It's super fascinating. It's actually, the most fascinating branch of machine learning, because this is the closest one to human intelligence. So now I just can't wait to see you in this next part to enter the world of deep learning. And until then, enjoy machine learning.